So boys, now we're going through rotational symmetry. So some of you may have had some trouble with this in Year 7, so I'm going to go through it again. A shape has rotational symmetry if it can be rotated through around a point through 360 degrees and land on top of itself more than once. So in other words, when you spin it around, of course when it gets back to the 360 degrees, it will be back on top of itself. So that doesn't actually count, okay? It counts in the order, which we'll talk about later, but it doesn't make it have any rotational symmetry. All right, so the centre of symmetry is the point that you're actually spinning around. Over here, the order of rotational symmetry is important. It's the number of times that that shape lands on top of itself. You can't have order 1. So like I was saying, if you spin around 360 degrees and you go, oh, okay, it fell on top of itself here, well, that's where you started. So we can't, it is order 1, but that's not got rotational symmetry. So we cannot have order 1. All right, so we're going to look through some examples here and see how this works. So in this first one, they're asking, decide whether the shape has rotational symmetry, and if it does, tell me the order. Okay, so here we have a square. I haven't marked in the equal sides or the right angles, but let's just assume it is a square. So get your red pen and put a dot, a point right in the middle. That's the centre of symmetry there. Okay, we're going to spin around that point. So if you can imagine, when we start to spin, when we move it through, let's go clockwise, which is the way the hands of a clock go if you've got an analog clock, not a digital one. So if the hands of the clock go around this direction, this is what we call clockwise. So I'm just going to rotate clockwise. It doesn't matter if you go the other way, but just so we're all talking about the same thing. So we're going to start here and we're going to rotate. Now, can you imagine if we spin this through 90 degrees, this side will move to there. Okay, so if you get a square piece of paper and do what I'm asking you to do, you'll see it. I'm just trying to see if I've got a square. I don't think I've got anything that's square here. You cut a piece of square paper out and you'll be able to see what I'm talking about. Okay, so if you get it like this and you spin it, it will look exactly the same as what it does now. It's just that that side has moved to there. If you spin it another 90 degrees, that initial side is now down here, and it still looks like the same square that it did a minute ago. And if you spin it another 90 degrees, that side is now around to here. And if you spin it another 90 degrees, it will get back to where it started from. So the square has gone from starting here, to spinning to there, to spinning to there, to spinning to here, and back again. So if we have a look at how many times the square actually looked like itself and landed on top of itself, well, it's 1 to get it to there, 2 to get it to here, 3 to get it to here, and 4 to get it back to where it started. So we're going to say, yes, it does have rotational symmetry, and it's order 4. You do include it going back to its original spot, but remember I said a minute ago, order 1 doesn't mean you've got rotational symmetry. Okay, now the next shape is a star. All right, it's a perfect star. It's got all these sides are equal and all these angles are spread, it's all spread out equally. Okay, so if I start up here at this point, well, our centre would be wherever you think the centre of the star is. We're spinning around that. Okay, now we're going to look at this point here. Now if we spin that star, I can get it to there. Now, it's a bit hard in this one to know how many degrees I've gone through to get it to there, but we can spin it, and that point will go to there. Okay, you can find out later how many degrees that is. We won't talk about that now. If we spin it a bit further, that point will move to here. Spin it a bit further, and that point will move to here. Spin it a bit further, and that point will move to there. Spin it a bit further, and you're back to where you started. So, when you got to here, the star looked at the same, it landed on top of itself, that's once. Spin it a bit further, lands on top of itself, that's two. Spin a bit further, it lands on top of itself, that's three. Spin a bit further, it lands on top of itself, that's four. And then if you spin a bit further, you'll get back to where you started, that's five. So yes, it has rotational symmetry of order 5. Okay, now the next question says draw a shape that has rotational symmetry of order 2. So that means that when we spin it for 360 degrees, it has to land on top of itself once, and then again when it's back to where it started. So there's a few different things you could do for this, but the easiest one that you could do is a rectangle. Okay, so watch what happens with a rectangle. You could draw a rectangle going that way, or you could draw it going long way, so it doesn't matter. So here's our centre. And then we're going to see what happens when we spin it. Now, if you take this side here, if you spin that through 90 degrees, watch what happens with my page. Here's my rectangle. If I spin that, here's my centre right in the middle, and try and hold it still. If I spin that clockwise, 90 degrees, watch what happens to it. That's what it looks like. It doesn't look like what it did when it started. Okay, so it hasn't landed on top of itself yet. Doesn't look like itself. So you don't count that. We'll have to spin a bit further. Now it does look like itself. Okay, so that's actually been a 180 degree spin. Okay, so if I draw a line so you can see what I'm talking about. Right, just say that's the top of my page where the red line is. And I've got a centre in the middle. Now if I spin 90 degrees clockwise, that's not what it looks like. The shape doesn't look the same. Go a bit further round. Now, that side is now down on the bottom, but the shape looks the same. Okay, so once it gets around to there, we've gone through a 180 degree spin, but it looks the same as what it did. So that's order 1, and then we go all the way back again, and that's order 2. So that any rectangle will work for that. You can pick other shapes that have got something similar going on if you want to be a bit more creative, but that's the easiest one. Okay, now over here, for this question, for both of these shapes, we've got 2 things to do. One is find the number of axes of symmetry, back to the line symmetry we were doing. And the second one is talking about the rotational symmetry. Okay, so let's look at this first shape. We're concentrating on axes of symmetry. So we've got to see where we can draw a line that acts like a mirror. Well, I can see that I can draw a line down there, and that would act like a mirror. So if I fold that shape, this half of it would fall over on top of itself over there. So that's an axis of symmetry. If you look very carefully at this, there is nothing else. Okay, so for part 1, it's got one axis of symmetry. So if I say axis, it means one axis. Axes means what? It means 2 or more. So when we start doing the plural of axis, we don't say axes, we say axes. Okay, and the second part of it, part 2, says, has this got rotational symmetry? And if it does, what order is it? Okay, so if we have a look at it, just ignore the red line, we don't need to be looking at that. All right, so I'm going to try and draw a T here for you on my paper that looks like that one. All right, there it is. Okay, so we're going to see what happens. It's a bit hard to see where the centre of symmetry would be. Probably there, maybe. Doesn't really matter in this case. We're just trying to see if it lands on top of itself. So I'm going to start to spin this shape clockwise, and we'll just see if it looks like that. Now remember what it looks like, because otherwise you're going to forget. You've got it in front of you over here anyway in your book, so it looks like an upside down T. All right, so we'll start to spin. Tell me if you think it looks like an upside down T again. Let's remember where I started. Okay, so we're starting up here, right? I'll just put a little dot up there so we can cross, so we know where we're starting. Okay, so when we get the cross back up to here, we're back to where we started. All right, so we're starting to spin clockwise. We're looking for an upside down T. Okay, it only looks like the upside down T when we get back to where we started. It doesn't look like an upside down T at any other time. So we can't have order 1, so we're going to say, no, it does not have rotational symmetry. Okay, for the next shape, we're looking at a hexagon. It's got 6 sides. All these sides are the same, they're all the same length. So first of all, we're looking at our axes of symmetry. So it might be a good idea, I'm running out of room here, but if you draw this shape twice so that you can do the axis of symmetry with your first shape, and then with the second shape, concentrate on your rotational symmetry, so it's not all over the place. I'm going to be rubbing out in between times. Okay, so for your axes of symmetry, we can go from this side, right in the middle of the side, to right in the middle of the opposite side. There's one axis of symmetry. You can see that this half, if we fold it there, would fall on top of the other half. So we're going to do the same thing all the way around this shape. So we're going from the middle of the side to the middle of the opposite side. So let's do the same here. Middle of the side to the middle of the opposite side. Middle of the side to the middle of the opposite side. And then we're going to start repeating ourselves, so we don't want to do that. So we've got 3 axes of symmetry drawn in so far. But there are another 3. I'll use another coloured pen for this. So if we go from this corner, we can go to the opposite corner. So from one vertex to the opposite vertex. And if you can think about it, this bit here would actually reflect on top of the other half, so it does work. All right, so we're going to go from corner to opposite corner. And from corner to opposite corner. Just rub part of that out, so I'll just fix it up. Okay, so if we count the red ones, we've got 3 lines there. If we count the green ones, we've got another 3 lines. So we've got 6 axes of symmetry. So if you go back and have a look at some of the other ones we did, I think we did a pentagon on the first video, and the pentagon had 5 sides, 5 equal sides, and so that has 5 axes of symmetry. This one has got 6 sides and it's got 6 axes of symmetry, so it will follow that way on anything shape that's a regular shape with all the sides equal. So you just got to find them and make sure you put them in. Alright, so remember with the pentagon, the odd numbers of shapes, you can't have a corner to opposite corner. So have a look back at what we did there. These ones, that's corner to opposite corner and middle of the side to the opposite of the middle of the opposite side. Alright, so the red ones and the green ones, they're all axes of symmetry. Okay, I'm going to rub this out now, and I'm going to draw it again so that you can see what we do with the rotational symmetry. But it would be a good idea if you draw the shape again, just the plain hexagon, like I'm about to do. And we're going to start again. Okay, so we're doing rotational symmetry, so the centre of the symmetry will be right in the middle, and we're going to rotate. Okay, so let's look at this side. Now, if we start to spin clockwise, we'll spin it a little bit, and that side will actually land on top of that side. So that's one. Continue to spin, and that side will move to here. Continue spinning and it will move to here. Continue spinning, it moves to here, then to here, and then back to the beginning. Okay, so that's just continuing to rotate the shape clockwise around our centre. So it has rotational symmetry. And its order is 6 because it landed on top of itself 5 times to get to there and 6 to get back to where it started. So really, this started off as a 6-sided shape. It's got 6 axes of symmetry and rotational symmetry of order 6. So if you're in an exam and you've got a bit stuck and you thought, I'm a bit confused, I don't know what I'm doing with rotational symmetry, if you can see it's a shape with all equal sides, count the sides. That should help you when you get stuck in a test question. Okay, good luck with your homework.